Welcome to our lesson Form 1, Particulate Nature of Matter, Lesson 5. Okay? This is about diffusion. In Lesson 4, we looked at the particle arrangements in solid, liquid, and gaseous state. So, we want to know what is diffusion. Diffusion is a process by which particles spread from a high concentration region to a low concentration region. So, we know matter is made up of particles. Our focus in this lesson is on two aspects of states of matter. One, liquid. Two, gaseous, gas. So we are dealing with liquid and gas. But in this particular topic, I'm dealing with only liquid. Gas will come later. Most of you may have passed where maybe there is a dead carcass of an animal somewhere. Okay? And when you pass there, you have a feeling by the sense of smell. Something wrong somewhere here. Okay? But you are not at the exact point where that smell is coming from. Yet, you can sense there is something wrong. Now, that is the core of our study today. How come you are able to feel there is something wrong, and yet you are not seeing any carcass somewhere rotten? The process by which particles reached you from the carcass where there is high concentration of those particles, that is what we call diffusion. So the particles have moved from high concentration region to low concentration region. I want you to give me one common process like that in a school situation when people have eaten beans, the day of beans. When you go to class, you can explain that. So let us now move from class. Let us move from that experience along the road. Let us move from your experience in class on the day of beans during lunch or supper. And now let us move to home, our homes. Okay? Our homes. Sometimes you have juice. Okay? And that juice, you can't drink it straight the way it is packed. Let me say some juice. Okay? You need to do one or two things before you take that juice. And finally, we move from home scenario to the laboratory. Let us focus down here now. I move the camera a bit there. We can get quite enough. Okay? So, you have here a funnel. You have a beaker. you have water and you have copper sulfate solution. Copper sulfate solution. Okay? Concentrated. So we have this process. Pour water into the beaker. So I will pour water into the beaker. Okay? Maybe 3/4, not to the brim. 3/4. I've started with water there. Then we pour concentrated copper sulfate using a funnel. We use this funnel. Now we pour concentrated copper sulfate. Okay? So we have here, I'm just doing this to help us understand. There. Okay? So I'm pouring down using a funnel so that this copper sulfate, this, there, I'm pouring it down, and there is water here. So you can see there is water. I'm doing that to make you understand because I had already drawn, but I'm making it more concrete now. Okay? We focus a bit. Yes. So the copper sulfate is here in blue. Okay? Now remove the funnel carefully so that you don't disturb. You don't disturb now the layers. You have used this funnel carefully. You have poured copper sulfate into your beaker. The funnel touches the bottom of your beaker. So as you pour copper sulfate, it goes right to the bottom. And since it is concentrated, it remains down. Why? Its density is more than water. Since water has less density, it will float. It will float. Okay? So, observation. I want us to go to observation. So, initially, water floats on copper sulfate. Water floats. Water floats on that. So, the diagram is trying to empower your thinking that initially there seem to be two distinct layers. Two distinct layers. Okay? The reason why water is up there, water is less dense. Down here, I have concentrated copper sulfate. But after some time, that boundary disappears. This boundary here. That line giving you a distinction of water and copper sulfate, that part disappears after some times. Why? Okay. Why? That is the core of this lesson. Why does it disappear? Now I want you to note two things. Copper sulfate has also small quantity of water in it because it is a solution. It is a solution. So there is just small quantity of water in it. So water from water layer, water from water layer, there is this water from here has come to the layer of copper sulfate. Copper sulfate has a small quantity of water. So water from water layer, which is highly concentrated, which is more, try to go to the water, little amount of water in the copper sulfate layer. So I'm using layer to show you movements. Okay, so water from water layer went into, we cannot say went into because you don't see it. It has gone. No, that's why I put in quotes for explanation purposes. So went into copper sulfate solution, which has less water concentration. So there are two things here. The water is purely water. The black is purely water. The blue, if you want to understand me, that you can see the blue now have put few black lines showing you that there is some small amount of water. So the first movement is that. There is also another movement which we have to perceive now. I'm down there. You can see black, black, black. There is blue. Overall is blue. But I've put that so that you get the understanding. This high concentration water area comes also to low concentration area in terms of water in copper sulfate. Then number 2, copper sulfate went into water layer because there is none of copper sulfate there. So you account for the two aspects. But the overall that we are looking at is copper sulfate going into water layer. So that process of spreading of copper sulfate into water is what we call diffusion. This, number 2, is more distinct, is more profound than 1. So copper sulfate diffused into water layer. After some time, after some time, so after some time, boundary disappears because of those movements. Okay? Then one pale blue mixture is seen. We see not 2 layers. One is a middle ground of water and copper sulfate, which is very blue in nature. But now we see something pale, not so much blue, not so much clean, but in between. That is what we see. Okay? So our conclusion is copper sulfate being at high concentration, the particles moved to water. Then you see that. So that is what we do to demonstrate the diffusion in liquids. I've used water, I've used copper sulfate solution, concentrated copper sulfate solution. Concentrated helps you to remember diffusion. Some say diffusion. Subscribe for the next so that we see the same but using gas, to investigate diffusion in gas, and then we shall conclude with the rates of diffusion. Rates of diffusion, that is comparison of diffusion. Subscribe, you get more. Form 1, Form 2, 3, and 4 is good for all of you. Bye-bye.